Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges and my courses are going to help the students who are preparing for CSIR NET, GATE, NT exam, PhD exam, SET exam, uh, Jest, Tifr, IIT-Jam exam and other exams related to physical science. And okay, so guys, it is the lecture number 8 for quantum mechanics PYQ. Okay, so I'm going to solve quantum mechanics PYQ. This is the lecture number 8. Before starting the class, I would request the people who haven't subscribed my channel yet, please subscribe my channel and watch my free classes, which are going to help you to crack the exams related to physical science. Okay. So I'm going to start now. So this is the lecture number 8 for quantum mechanics PYQ. Meanwhile, just let me check the sound. Am I audible or not related to physical? Yes, I'm audible. Okay. So I'm going to start now. Question number 1. Okay. And this is very good question, guys. Two and very logical questions. Okay. So you need to revise this. You need to revise this question. So I'm going to write it. It's two identical bosons. Two identical bosons. Two identical bosons of mass m of mass m are placed in are placed in a one-dimensional a one-dimensional a one-dimensional potential that is p, which is function of x, equal to half m omega square, half m omega square x square. Okay, this is the potential which is given. The bosons the bosons interact via weak a weak potential a weak potential that is V12 equal to V naught exponential minus m capital Omega x1 minus x2 whole square upon h4 h cut square. Okay, this is the weak potential is given. Okay, where x1 and x2 denote coordinates of the particles, given that the ground state wave function of the harmonic oscillator of the harmonic oscillator is psi naught x, which is function of x, is given m omega pi h cut to the power 1 by 4 e to the power minus m omega x square upon 2 h cut. Okay, so this is the ground state wave function of harmonic oscillator is given, and the ground state energy of energy of the two boson system to the first order in V naught is okay, and options are given A equal to h cut omega plus 2 V naught, B equal to h cut omega plus V naught capital omega upon small omega, and option C is given h cut omega plus V naught into 1 plus capital omega upon 2 small omega to the power minus half, and option D is given h cut omega plus V naught 1 plus small omega upon capital omega. Okay, so this is the question, guys. I'll read it for you again. Okay, so this is given two identical bosons of mass m are placed in one-dimensional potential. Okay, harmonic potential, which is given half m omega square x square. Okay, the bosons interact via a weak potential, which is given V12 is given V0 exponential minus m omega x minus x2 whole square upon 4 h cut square. Okay, this is the weak interaction potential given. Okay, where x1, x2 denote the coordinates of the particles, given that the ground state wave function of the harmonic oscillator, okay, so the ground state wave function is given, that is psi naught x, which is given m omega upon pi h cut to the power 1 by 4 e to the power minus m omega x square upon 2 h cut. The ground state energy of the two boson system, okay, to the order to the first order in V naught is, okay, we need to find out ground state energy. So very good question. I will explain it. So now I'm going to solve it. Okay. So we know there are two bosons trapped in the harmonic oscillator, right? So there is a system of two particles which is in one dimensional harmonic oscillator, okay? So two bosons are there. So the energy for ground state without perturbation is going to be, okay, so energy for ground state, energy for ground state, energy for ground state without perturbation, without perturbation is, so energy for ground state without perturbation, so is going to be, because there are two particles, so we know the ground state energy of any particle which is in 1D, right? 1D harmonic oscillator, that we know h cut by 2, right? H cut omega by 2, that's we know, because the energy is like this, you know, right? That is h cut omega into n plus half, right? So for ground state n equal to 0, so it is going to be h cut omega by 2, right? So here there are two particles, so energy is going to be two particles, so we'll multiply by 2, right? So it is going to be h cut omega. So ground state energy is h cut omega. Ground state energy of the particle of two system is h cut omega, okay, without perturbation, when there is no perturbation is done, okay. So this is the one, okay. So now if perturbation is introduced, so we have so okay, so if perturbation is introduced, so we have to calculate average of V12, right? So this is the perturbation. So if perturbation is introduced, if perturbation is introduced, if perturbation is introduced, we have to calculate, V12, okay. And V12, where V12 is given, that is, yeah, V12 is given, and that is V0 exponential minus m capital omega x1 minus x2 whole square upon 4 h cut square, right? This is given. So okay, so if you so now we know this, right, perturbation, so we can calculate this V0. The one procedure of calculating this expectation, this this average of V1, right, V12 is like what we are going to do, we have been given that psi, right? We can psi naught x V12 psi naught x, right? This is the one way. And but so here we'll put the value, and this is going to be integration we'll put this value of this and v naught this value, right? And then this integration is going to be very tedious task, okay, very tough. So we'll not do like that, okay? So this is going to be very lengthy. So instead of it, what we are going to do is, which I'm going to tell you, okay? So this is a very lengthy process, which we are not going to do, okay? So what we are going to do is now, so we'll use trick here, okay? We'll use trick, okay? So trick says the perturbation is, we know the perturbation. So V12 is perturbation, guys, here, okay? The perturbation is nothing but an approximation used in Taylor series, okay? Used in Taylor series, okay? So perturbation is nothing but an approximation used in Taylor series. So what approximation we use in Taylor series, that is the perturbation, okay? So so what we can do is, so we can just expand this in Taylor series, okay? So we can do just expand, this is a very good question, guys, okay? We need to practice it and revise it. So this is just expand V12, okay, and take the average value, okay, and take the average value of V12. We'll take first two term, okay? So expand V12 and take the average value of V12, right? So that from there also we can get the value of this one, okay? So what we are going to do now is V12, which is already given, okay? So here what we are going to do is, we'll take the average. First we'll write it as it is, okay? This is this one, V12, and this we are going to open it. So this is e to the power, this is going to be 1 minus m omega x minus x1 minus x2 whole square upon 4 h cut square, okay? Then so on, because we know here, all right, e to the power x is 1 plus x square upon 2 factorial plus so on, okay? This we know. So we have expanded, okay? So we have expanded this, okay? Because perturbation is nothing but an approximation used in Taylor series, okay? So this one, so this is the value, guys, okay? Well, so this is the one, and now we'll take the average of it. Instead of doing that tedious task, right, we'll solve like this, okay? So we'll take out the average of this, okay? So this is going to be V naught into 1 minus m omega x minus x1 minus x2 whole square upon 4 h cut square plus 1. We'll take first two terms only, okay? Right, so this is the one. Now we are taking the average, right? So this is going to be average, okay? So we'll open it. So it is going to be average of V12. So we are using the trick, guys, okay? So this is V naught, and this is going to be 1 minus m omega, this is going to be x1 square, take an average, plus we have opened x1 minus x2 whole square, okay? And then x2 square average plus 2x1 x2 upon 4 h square plus so on, right? So this is going to be v12, okay. So this is going to be v0, okay, 1 minus m omega. So we know, right guys, so we know expectation value of any this one expectation value of this x, this is position, right, is going to be 0. x1 x2 expectation value of x1 x2 is 0, right guys, we know it. Okay, so well, so and the value of this x1 square also we know, the expectation value of x1 square or x square, right, we know this is expectation value of x square, this is position, we know that is h cut upon 2m omega, okay. So this we know, so we'll put the value here, okay. So this is the one, guys, okay. So this we know, h cut upon 2m omega, okay. So we'll put the value. We have already solved this expectation value of momentum square and expectation value of the position square, okay, square of position, okay, that is this one, expectation value of x square and expectation value of p square, right, that we have already calculated. So we'll put the value here, so it is going to be m omega, and this value is going to be h cut upon 2m omega, okay, plus this value is also going to be h cut upon 2m omega, okay, and this value is going to be 0 upon 4 h cut square, okay, plus so on, okay. So this is going to be v12 average, it's going to be we'll solve it, right. So this is going to be v0 minus, this is going to be v0 is common, 1 minus omega upon 4 omega, okay. This is the value we have got after solving this. Very simple. Will get cancelled, h cut will get cancelled with this, okay, and so this is just the h cut, guys, not h cut square, h cut, not h cut square, okay. This is h cut in question, okay. Yes, this is h cut, not h cut square, okay. So this is the one, and h cut will get cancelled, okay, and this is going to be h cut upon 2 omega, and this is h cut upon, sorry, h cut upon 8 omega, and this is h cut upon 8 omega. So this is going to be h cut will get cancelled, so this is going to be omega upon 8 omega plus omega upon 8 omega, so this is going to be omega upon 4 omega, okay. So this is the one, this is small omega, okay, and we can write this like this as well, or this is also going to be, so we have ignored higher terms, okay. We have just taken first two terms only, So we can write this as well. This is almost going. This is also going to be almost equal to V naught into 1 plus omega upon 4 omega to the power minus half, right? Because we know 1 plus x to the power n, it is 1 plus nx, right? So yeah, this is going to be 2 omega, sorry, 2 omega, right? So this is going to be nx, right? So if you open it, if you take only first two terms, so it is going to be 1 plus uh, omega minus omega upon 4 omega, right? So this is going to be almost equal to this, okay? Nx plus so on. If you open this, okay? So this is going to be V12 average, okay? We have found like this, okay? By expanding Taylor series, and then we expanded V12 and then we have taken average, okay? From by this trick also we can get this value, average value of V12, right? So now we have got this one. So now the energy is going to, ground state energy is going to be E. So we know that ground state energy is going to be ground state energy, we know without perturbation, that is h cut omega. I have already explained, okay? And plus the perturbation, the energy because of perturbation, and that is going to be V naught uh, V naught into 1 plus capital omega upon 2 omega to the power minus 1 by 2, okay? So well, this is the answer, guys, okay? So which option is matching? Let me check. So option number C is matching, guys, okay? H cut omega plus P naught 1 plus omega upon 2 omega to the power minus half, okay? So this is the correct answer, guys, okay? This is the E, okay? So we have taken this average value and then we have taken the energy, ground state energy, okay? This is for because of two particles, and plus this is due to perturbation, okay? This is the total energy, guys, okay? So next question, question number 2. It is very good question, guys, so you need to practice and revise this question. Next question is, this is also a good question. Question is, a spin half particle, a spin half particle a spin half particle is in the state in the state chi equal to 1 upon root 11 1 plus iota up 3, okay? This is in matrix form, in the state, in the eigenbasis, in the eigenbasis of s square and sz, okay? If we measure, if we measure sz the probabilities of probabilities of getting plus h cut by 2 and minus h cut by 2 respectively are. Okay, options are given. Option number A, 1 by 2 and 1 by 2. Option B is 2 by 11, 2 by 11 and 9 by 11. Option C is 0 and 1, and option D is 1 by 11, 1 by 11 and 3 by 11. Okay, so question is, I think I'm audible, guys. I'm just checking it. Okay, just give me 1 second. This is also good. Yes, audible. Okay, so the spin half particle, a spin half particle is in the state chi is given. Okay, in the eigenbasis of s square and sz. Okay, if we measure sz, z component of spin. Okay, so it is spin component, and this is spin. Okay, sz, the probability of getting plus h cut by 2 and minus h cut by 2 respectively, you need to find out. Okay, so we have been given chi, the eigenstate is given chi equal to 1 upon root 11 1 plus iota 3. Okay, so this is given. Okay, so we need to find the probability of getting h cut by 2 or minus h cut by 2. Okay, so sz we know, right? Sz equal to h cut sigma z, or that we can write h cut sigma z value is 1 0 0 minus 1. Okay, this we know, and from there we get the value of sz, that is the eigenvalues that are h cut plus minus h cut by 2. Okay, we get lambda plus minus h cut by 2. This we know. I have solved this question already in my previous lectures. Okay, so this we know. So now we need to find out probability of getting plus h cut by 2, and this we have been given this chi equal to this, so we can write this like this also, 1 upon root 11, okay, into 1 plus iota 3, because we need to find out, we are measuring sz. Okay, and then probability of finding out probability of getting h cut by 2 and minus h cut by 2 we are finding. So we can write like this also, we can write C1 10 plus C2 01. Okay, we can write this as like this also. I solved the same type of question earlier as well in the previous class. Okay, C2. So now, or we can write like this also. So we can write this 1 upon root 11 1 plus iota 10 plus 1 upon root 11 3 into 3 into 01 equal to C1 01, sorry, C1 10 C1 10 plus C2 01. Okay, so now we can compare. By comparing, C1 is going to be equal to 1 plus iota root 11, and C2 is going to be 3 by root 11. Okay, after comparing, so now we know the probability of getting plus h cut by 2 is going to be, we know that is C1 mod square. Okay, so this is going to be C1 is 1 plus iota, this one 1 plus iota upon root 11 mod square. Okay, and this we know this is going to be 2 upon 11. Similarly, probability of getting minus h cut by 2 is going to be C2 mod square, right? C2 mod square, and this is going to be this is this one, right? 3 upon, so 3 upon root 11 mod square, right? And we know that is going to be 9 upon 11. So therefore 2 by 11 and 9 by 11 is the correct answer. So which option is matching? So the option number B is matching. Okay, so option number B is the correct one, guys. Okay, so very simple question, and now you understood how we are going to solve this type of question. Okay, similar question I have solved in my previous lectures of the PYQ, so you can check it as well. Okay, so this is the answer. So option B is the correct answer for this question. Okay, very simple one. Okay, so this is the one. Okay, so next question, question number 3rd. Question number 3rd we are going to solve. This is also a very good question, guys. The motion of a particle of mass m, the motion of a particle of mass m, in one dimension, is described by the Hamiltonian h equal to p square upon 2m plus half m omega square x square plus lambda x. Okay, what is the difference? What is the difference between the quantized, okay, energy, quantized, between the quantized energies quantized energies quantized energies of the first two levels of the first two levels expectation value of x is average of x is the expectation value of x is the expectation value of x in the ground state okay. So here average of x is the expectation value of x in the ground state. Okay, and options are given. Option number A is h cut omega, very good question, minus lambda x. Option B is h cut omega plus lambda x. This is expectation value of x. Okay. Option C is h cut omega plus lambda square upon 2m omega square, and option D is h cut omega. Okay. Okay, so this is the question. Okay. The question is, the motion of a particle of mass m in one dimension is described by the Hamiltonian. Hamiltonian is given. Okay. What is the difference between the quantized energies of the first two levels? So energy difference between first two energy levels we need to find out. Okay. So these are the options given. Okay. So I'm going to solve now. Okay. Okay. So Hamiltonian is given. So I'll write Hamiltonian is given. So Hamiltonian is given, that is p square upon 2m plus half m omega square x square plus lambda x. Okay. So this means the potential energy, which is equal to half m omega square x square, m omega x square, omega square x square, and lambda x, right? So now we'll find out Vx is going to be, because if this would be the only term, then we can easily find the difference, right? But there is lambda x as well, so we need to solve it. So this is going to be half m omega square, we are going to take common. Okay, so this is going to be x square plus, this is going to be 2 upon, so here we have taken half m omega square common, right? It is remaining, the first term remaining is x square, because this we have taken the common, and here it is going to be 2 upon m omega square lambda x, right? Because if you multiply this, so this omega is going to get cancelled, 2 is going to get cancelled, and this is going to be only this lambda x value, right? This term, hope you understood this step. Okay, so this is going to be, Vx is going to be half m omega square is a common, so here we can say, we can also do like this, x square plus 2 into x into lambda upon m omega square, we can write like this. Okay, I'm writing like this because I'm going to make it a perfect square. Okay, m omega square. Okay, so this is x, 2 into x. Okay, so I can add here lambda square upon m square omega square, means lambda upon m omega square whole square, right? This is going to be this, we can add it, and also we can subtract it, lambda square m square omega square, for making perfect square, right? We have added this and subtracted this, so this is going to be perfect square. Okay, then Vx is going to be half m omega square okay, so this is going to be half m omega square, and this will be x plus lambda upon m omega square whole square, right? And this is going to be, we'll multiply this with this, so this is going to be minus lambda square upon, this is omega to the power 4, guys. Okay, omega to the power 4, because the whole square of this is going to be omega to the power 4. So this is going to be lambda square upon 2m omega square, right? Because the omega will get cancelled, so omega square will get cancelled with omega 4, so this omega 2 is omega to the power 2 will remain, and get cancelled, right? So this is going 1 will remain and 2 is there. Okay, so this is the one. So now we have got value of Vx. Okay, so this is the value of Vx, or we can write here. So we have made this in this form, right? So also we can write like this: Vx minus, this is minus, right? We'll take it this side, and this is going to be plus lambda square upon omega square, sorry, m square. This is going to be lambda square upon 2m omega square, 2m omega square. We have taken this part. This is in left hand side. Okay, this is going to be x plus lambda upon m omega square. Okay, this whole square. Okay, so we can say this. We can say this as a v dash, right? Let this term is v dash, and this is x dash square, right? Half m omega square is also there. Okay, this one. Half m whole square, right? So this is going to be half m omega square x dash square, right? X dash square, right? So this term we have say this is the x dash and this is the v dash. Okay, so this is the one, right? Now this is in the form of like this: half m omega square x dash square, right? So the energy is going to be E dash is going to be h cut omega into n plus half, right? Because if any term is like in this form, right, v equal to half m omega x square, in that case the energy we know h cut omega n plus half, right? Now we'll put the value of E dash. E dash is going to be uh, E plus this we have this is the V dash, right? V dash. So this is going to be h cut omega here. Will put the value. So V dash is this. So this is going to be energy, right? Ground state energy E plus this value is this one. We say this is the E, right? And this is going to be lambda square upon 2 m omega square, right? So this is going to be energy is going to be total energy is going to be E dash, right? E dash. So it means the energy is going to be, so we'll put here value of E dash, right? So this is going to be E plus this one lambda square upon 2m omega square. Okay, and this is going to be h cut omega into n plus half. E dash is the total energy. Okay, this is E dash is like this. E dash is E plus, or we can say kinetic energy, right? Oh yeah, E plus this one lambda square 2m omega square, right? So this is going to be like this. Okay, so then value of E is going to be this one, h cut omega into n plus half minus, this will go this side, right? So it is lambda square upon 2m omega square, lambda square upon 2m omega square, lambda square upon 2m omega square. Okay, this one. Now this is the value of E. So we have to find out the energy difference, or we can say En. Okay, here we can say En dash. Okay, this is En. Okay, because the total energy En dash is going to be like here, H is there, right? The H dash is going to be this one, this plus this, complete. Okay, so this is the energy. So now first the energy difference between first two levels. So first two level means E1 minus E0, right? That is the energy difference, and that is going to be for E1 we'll put the value n equal to 1, right? So this is going to be 3 h cut by 2, right? Because he will put 1 here, so it is going to be 3 by 2. So 3 h cut by 2 minus lambda square upon 2m omega square minus E0. Here we are going to write n equal to 0, so it is going to be h cut omega by 2 minus minus plus lambda square upon 2m omega square. Okay, this will get cancelled, so this is going to be 3 h cut omega by 2 minus h cut omega by 2. Okay, and this value is going to be h cut omega. This is the answer. Okay, so which option is matching? So option number, very good question, guys. Okay, so for because there is a lambda x term, that's why we have made a perfect square, then we have found and we have changed this into this form. Okay, m omega square x square, and put the value and got the energy, and then the energy difference is this. Okay, so this is the answer is option D is the correct option, guys. Okay, h cut omega, option D. Okay, guys, very good question. So practice it and revise it. Okay, so this is the answer. Now question number 4. Question number 4 we are going to solve. Question number 4 is, this is also a good question. Let psi NLM, let psi NLM denote the psi NLM denote the eigenfunctions 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 of a Hamiltonian for a spherically symmetric potential, spherically symmetric potential VR. The expectation value of LZ expectation value of LZ in the state psi equal to 1 by 6 psi 200 plus root 5 210 plus root 10 psi 21 minus 1 plus root 20 psi 211 is okay. Options are option number A -5 upon 18 h cut. Option B is 5 upon h cut, sorry, 5 upon 6 h cut, 5 upon 6 h cut. Option C is h cut, and option D is 15 upon 18 h cut. Okay. So this is the questions. Let psi NLM denote the eigenfunctions of a Hamiltonian for a spherically symmetric potential VR. Okay. The expectation value of LZ in this state, this you need to find out. Okay. So these are the options. Okay. So I'll solve it now. Okay. So we have been given wave function. Okay. So wave function is given, that is psi 1 upon 6 psi 200 psi 200 plus root 5 psi 210 plus root 10 psi 21 minus 1 plus root 20 psi 211. Okay. So this is given. This is the wave function which is given. Okay. So we need to find out the expectation value, that is LZ. Okay. LZ. So LZ is going to be psi LZ psi. Okay. Because this is a normalized wave function. Okay. Psi LZ psi. And now we know here, if we operate LZ with psi, okay, this is going to give MH cut psi. Okay. MH cut. Okay. So these are NLM, right? So here we'll find out. So we'll put this value because cat psi is this. Okay. So bra psi is going to be the same because there is no iota term. Okay. So we'll find out directly. Okay. So MH cut. So from here, M is 0. So it is going to be so I'll write it. Okay. So this is going to be like this, 1 upon 36. Write this psi 21200 plus root 5 psi 210 plus root 10 psi 21 minus 1 plus root 20 psi 211. Then here is going to be LZ. Okay. And then again psi, because 1 upon 6 I have taken here 136. So this is going to be psi 200 plus root 5 psi 210 plus root 10 psi 21 minus 1 plus root 20 psi 211. Okay. So we'll solve it. Okay. So now if we operate LZ with this is going to be, for this it is going to be MH cut. Okay. M is 0 here. Okay. So this value is going to be, if we solve it, so it is going to be 1 upon 36. Okay. Very simple. I have solved many questions, similar questions. Okay. So this is 1 upon 36, and this is going to be psi 2 psi 20. This is 1, right? Where the, and this is going to be LZ and MZ. So this is it's going to be 0 into h cut, and because value of m is 0. Okay. H cut plus this is going to be 5 into h is here again 0 into h cut. okay, plus here 10, this is going to be 10, L is minus 1, so minus h cut, okay, plus this is going to be 20, because this 20 will multiply, this is going to be 20, psi 1 psi 1, this is going to be 1, okay, so 20 minus, this is just h cut, because not minus is there, okay, minus, this is 1, m is 1, so h cut, okay. So this is going to be 1 upon 36, and this value is going to be minus 10 h cut plus 20 h cut, okay. So this is going to be 10 h cut upon 36. 10 h cut upon 36, or we solve it, so this is going to be 5 h cut upon 18, okay, 5 h cut upon 18. So which option is matching? Option D, okay. So option D is the correct option, this one, option D, okay. Okay, there is one more question remaining, and time is over. Let me check. So we'll solve this one as well, okay. So question number 5, guys. Question number 5 is, if psi x, if psi x equal to a e to the power minus x to the power 4, okay, is eigenfunction of one dimensional, of a one dimensional Hamiltonian, with eigenvalues, with eigenvalues equal to 0, okay. The potential Vx in units where h cut equal to 2m equal to 1 is, option A is 12x square, option B is 16x to the power 6, option C is 12x to the power 6, sorry, 16x to the power 6, 16x to the power 6 plus 12x square, and option D is 16x to the power 6 minus 12x square, okay. So this is very good question, okay. The question is, the psi x is given, the wave function, okay. So psi x equal to e to the power x to the power 4 is an eigenfunction of one dimensional Hamiltonian, okay, with eigenvalue equal to 0. The potential Vx in units h cut equal to 2m equal to 1 is, okay. So you need to find out the potential. So we'll use Schrodinger equation here, guys, okay. Well, I'm going to solve it. So we know the Schrodinger equation. we know the Schrodinger equation, okay, that is for 1D it is going to be minus h cut square upon 2m, okay, del square upon del x square psi plus Vx psi equal to E psi, right? This is the Schrodinger equation. So here it is given h cut equal to 1 and 2m equal to 1, right? So this is going to be minus del square psi upon del x square plus Vx psi equal to E psi, okay? And E is also given 0, so the equation is going to be minus del square upon del x square. The value of psi is a e to the power minus x to the power 4, okay, plus v psi, okay, Vx function of x, Vx, or we can write v only, okay. So this is going to be psi e to the power minus x to the power 4 is going to be 0 because e is 0, okay, since e is 0 given, okay. Now we'll solve it. We just need to solve it and find the value of v, okay. So we'll differentiate it. So it is going to be del upon del x. We'll differentiate first. So it is going to be a will be here, right, or a is there, so a will go in right hand side. So this is going to be 0, so no need to write a. So it is going to be like this. So e to the power minus x to the power 4 into minus 4x cube. We have differentiated it once, okay, and this is Vx e to the power minus x to the power 4 is 0, right? So again we'll differentiate it, okay. So this is going to be, so here minus minus is going to be plus, and we'll take 4 common, so it is going to be 4d upon dx x cube e to the power minus x to the power 4 plus v with function of x e to the power minus x4 equal to 0. Now we'll solve it. So this is going to be 4 is a common, so first function x3 e to the power minus x to the power 4 into minus 4 x cube in differentiation of second, okay. Then second function will remain as it is, x to the power 4, and differentiation of first, so this is going to be 3x square, right, plus Vx e to the power minus x4 is going to be 0. So e to the power x4 is in all terms, so it will go in right hand side, so this is going to be 0, and then and we'll solve it. So this is going to give Vx is going to be that is 16x to the power 6 minus 12x square, okay, because what we have done is e to the power minus x4 we have taken in right hand side became 0, okay, and then this is going to be minus 16 x cube, right, x to the power 6 plus this is going to be 12x square, right, and then plus Vx equal to 0, so value of Vx is going to be this. So this is the answer, guys. So which option is matching? Let's see. Option D is matching, right? Yes, option D is matching. So this is the correct option. Okay, guys, so I'll stop here now, and thank you so much for watching my lecture, guys. And also I would request the people who haven't subscribed my channel yet, please subscribe my channel and watch my lectures, which are absolutely free of charges and going to help you to crack the exams related to physical science. Okay, guys, thank you. Bye now.